Video, I will be introducing key features of a parabola. So in the last unit, or at last part of Module 2, we learned to factor quadratic trinomials, which are quadratic polynomials. When we graph these quadratic polynomials, we call them functions. So now we're going to be looking at the graph of these U-shaped functions, and the first thing I want to do is talk to you about key vocabulary. So this is it in terms of notes. I need part of it anyway. I need you to copy down this vocab. I will link this if you have a preference of printing this, if you have that capability, and then you may annotate on the side the things I write here on the right side of the screen. So I'm just going to go through the vocabulary and explain it, and over here kind of draw some pictures. So a quadratic function is a polynomial of degree 2, or simply a quadratic. It's a polynomial function that has one or more variables in which the highest degree term is of the second degree. So the highest exponent is what we're referring to, and its value is 2. So when the highest exponent of x is 2, it is known as a quadratic function. One thing that always must be true is that the a value, I should have put quotes around that, sorry. I can't fix that now, but the quote a cannot ever equal 0, because if a equaled 0, then 0 times the x squared term would make it go away, and it would no longer be a quadratic function because we would just have this bx plus c, which actually graphs as a line. So if you're listening, underline bx plus c and put line, but understand that if it's ax squared plus bx plus c, then it will be a parabola, which is our next vocab word. So a parabola is a U-shaped graph. The most basic function we can graph is y equals x squared, okay? So it's a U-shaped graph. In fact, if I go ahead and graph this, creating a table of x and y values, some of the most basic ones we might use are -2, -1, 0, 1, and 2. And I want you to think about what happens when we plug those in. When we substitute -2 into here and do -2 squared, it equals -2 times -2, which is 4. If we substitute -1 in for x, then -1 squared is 1. If we substitute 0, 0 squared is 0. 1 squared is 1. And 2 squared is 4. So if I graph these order pairs, -2, 4, -1, 1. I wanted to review this also in case you kind of forgot about how to graph ordered pairs. So remember that your x coordinate is the x-axis is the horizontal axis that goes left and right. The y-axis is the vertical axis that goes up and down. So when I read these ordered pairs like -2, 4, that tells me from 0 to go left 2, up 4. Here would be from the origin, left 1, up 1. Then we have a point at 0, 0. Then at 1, 1. And at 2, 4. So right 2, up 4. So this would be our graph of our parabola. Y equals x squared. It's the most basic. In fact, we call it the parent quadratic function. All right, so that's what we mean by parabola because it is U-shaped. All right. Your x-intercepts are also known as your zeros, roots, or solutions. In your Delta Math assignment, I consistently use the term zeros, but understand that anywhere you read about quadratic functions, if they mention x-intercepts, they could also use zeros, roots, or solutions interchangeably, and it would simply mean what's highlighted here, which is they are the point or points where the graph crosses the horizontal, meaning left and right, x-axis. Okay, so notice it's always the point x0. So if right now I ask you what is the 0 or what is the x-intercept, I would want you to write that it is the point 0, 0. Next, vocab y-intercept. Now, of course, you're writing down, so guys, feel free to pause it at any time. So y-intercept, it is the point, and there will only be one, where the graph crosses the vertical y-axis. So vertical is up and down. So I've got up and down in here and highlighted in your vocab, but this is our y-axis. So it is the point where it crosses the y-axis. Well, in this case, our y-intercept is also 0, 0. It isn't always the same as our 0 or x-intercepts, but sometimes it is. It is in this case. The vertex is the maximum or minimum point on the graph. So maximum, think highest. Well, the highest right here, it goes up forever, so technically there is no highest. Or minimum point of the graph. So I do have a minimum point, and it's right here. So guess what this also is? It is the vertex, and it happens to be 0, 0. And this always will be true for the function y equals x squared. We will do one in just a minute where it's different. So again, this would be known as a min because it is the bottommost point, the bottommost, lowest point. So again, maximum is going to be if it opens up, but we'll talk about that in a minute. So next here again, vertex. If the a value is positive, it will always open up. Well, if I were to think of this as the function like y equals ax squared plus bx plus c, what does that mean for this function? Well, it means that a is an understood 1, so this is 1x squared. If I am missing the linear term, that means my b value is 0, so plus 0x. And if I am missing a number after this term or the x squared term, then it is also 0. And of course, 0 times x is 0. Adding 0 does nothing. Multiplying by 1 just leaves us with x squared. But it is a quadratic in the form ax squared plus bx plus c. So when I talk about the a value for the vertex, if my parabola, if my function has a positive a value, I know it's going to open up, just like it does when y equals x squared. And we'll do an example in a minute that shows when the a value is negative, it will open down. So I just want you to think in terms of the vertex. What is the lowest or the highest point on the graph? So that's why I have that here. The lowest point is right here. Next, we have an axis of symmetry. An axis of symmetry is a vertical line that visually cuts the parabola in half. So if I said, use your finger and show me where it cuts it in half, I'm going to use a pencil actually. Where does it cut in half? You would say it cuts it in half right there, right down the middle. Well, that happens when the x value is 0, because that's the origin, 0, 0. So we usually draw an axis of symmetry as a dotted line because it's not really part of the graph. It just kind of visually helps us to see the middle. And the equation of your axis of symmetry in this case will always be x equals the x from the vertex. So over here in your vocab, I've got the equation of a vertical line that visually cuts the parabola in half, goes right down the middle through the vertex. I should have closed that off with parentheses, so in your notes, please do that. The equation of the axis of symmetry will always be x equals whatever the x is from the vertex. So I'm going to write it as x equals the x from the vertex. Well, that was 0, 0, so I'm going to put x equals 0. It's always the x value. So over here in your notes, I added, if the vertex was negative 5, 2, then your axis of symmetry would be x equals, guess what? The negative 5, the x value. If my vertex was at 0, negative 3, the axis of symmetry, should be a capital S, I got some typos in here, is x equals the 0 here from the order pair, the x value. So it's that simple. So lastly, I want to talk about domain and range. So domain are all the x values that exist on the graph of the function. Well, this, if you think about this table, I could go on and on forever. I could plug in a negative 3, a negative 4, a negative 5, a negative 100, a negative 2 trillion. And likewise, I could do the same this way. So this x goes on and on forever, just like our x-axis. Now, we only draw a small portion of it, but this graph, it goes on and on. So far, I would run out of paper. It just keeps on going and going forever. So domain describes what the graph is doing as x goes positive towards positive infinity and as it goes left towards negative infinity. Well, notice that our graph goes left and right forever. So if it goes left and right forever, our lowest x, even though technically you cannot find negative infinity on a number line, because it just is a concept that goes on and on forever, our domain will always be negative infinity to positive infinity. So look over here in your notes. It says, write it as your lowest x to your highest x. Well, my lowest x is negative infinity. We always write the lowest on the left, so keep that in mind, LL, lowest value on the left, and your highest x on the right. Well, in particular, for all polynomial functions, and that means lines, parabolas, and in your next course you'll do cubic functions and quartic functions. If it is a polynomial, then the domain will always be negative infinity to infinity. Now this is how we write it, but in Delta Math, I'm not able to type that in. So you have to write it in with no spaces in between as parentheses negative INF, comma, INF, and then your right parenthesis, okay? So I just have a couple notes down here that the infinity symbol is called, quote, infinity symbol, and it looks like a sideways 8. So some students actually take their paper and turn it and write it like an 8 until you get the hang of writing it. Negative infinity means we are going left forever if we're talking about domain. And for range, which we'll talk about in a second, that actually is our y values going up and down. So on a graph, I can go ahead and add in for my x-axis and y-axis if I wanted. Negative infinity means I'm going left forever on the x, but down forever on the y. Positive infinity means I'm going right forever on the x and up forever on the y. So negative infinity, again, I explained that here. Negative infinity means the graph goes left for domain or down for range forever as the values go more and more negative forever. Positive infinity means the graph is going more and more, oh, that should have been positive. Let me fix that. So do not put negative. If you are listening, when I check your notes, I'm going to be looking for that to say positive forever. If all you do is copy it, it's going to be wrong. So, and that means you're not listening. So make sure you change that to positive if you already copied it down. Just erase that, okay? Or scratch it out. So on Delta Math, again, every time you type in domain for parabolas, this is your answer every time. So with no spaces, this is what you're going to type in. So put a big circle around it in your notes so that when we do an example on Delta Math in a minute, you'll see that that's the correct answer. The range, new vocab word here, are all the y values that exist on the function. We write this as the lowest y to the highest y. Well, if we take a look at our graph, and I have to find the domain, I usually do D colon, but I'll write out the word, domain. My lowest x value, let me fix this. Domain was negative infinity to infinity. My range would be my lowest y to my highest y. So I want you to hold a pencil vertically, and you can do this when you're doing it on the screen, and go, all right, if it opens up, then my lowest y is right here. My lowest y occurs at my vertex. The lowest y is the y from the vertex, which happens to be 0. So clearly we need another example here, right? So my lowest y is 0, so I'm going to write that on the left because it's my lowest, and I always put lowest number on the left. My highest, well, it goes up forever. Well, what concept means up forever? Infinity. So I'm going to come over here for my range, and it would be 0, infinity. But this is something new too. When I write range, I always put a parent. It's actually called a right parent here because it's on the right side. And actually, parent is singular for parentheses. Did you know that? Singular is parent. So parentheses means 2. Parent, it could be a left parent or it could be a right parent. But parent is singular. Another word, by the way, just because I'm kind of a word nerd, parenthesis is also singular. So parent or parenthesis, but parent is just shorter and easier to say. So that would be a left parent and a right parent. What you need to understand, though, is for range and domain, If it is not infinity, we put a bracket, a solid bracket. Brackets mean it definitely equals 0. This is a stopping point. Think brackets like you ran into it and it stopped you. So bracket, 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 remember that. But always a paren around your infinity, okay? So that describes your all of your vocab that you need for this unit. Like I said, feel free to stop this, rewind it, re-listen, whatever you need to. But I'm going to now switch over and we're going to do another example. But there was a graphic organizer on your assignment today. So on your announcement for today, it said use the graphic organizer attached. So you can, if you click on it, it might take you to another page, but I actually have it attached right here. So if you want to print it, you may. So mine downloads it, and then I can print it, right? I can just hit print if you have that capability. And we are going to just do standard form today because there's just one thing I need to mention really about standard form to help you with your assignment. If you do not have the capability to print, then certainly just write the picture of this in your notes. So again, I'll open it. And you can hit pause to copy and maybe take your paper and divide it into 4 sections. And we're going to fill in standard today, vertex tomorrow, and then factored form the next day. Okay? So keep this organized in your notes or print it out and do not lose it. But it is attached right there on your announcement for today. All right? So I'm going to be using a copy of this, but certainly, like I said, you can keep it in your notes. And I want you to kind of keep this handy to the side as you are filling this out as we talk about this. So there are 3 different forms of quadratic functions, and the one that is standard form is the same one from your notes, ax squared plus bx plus c. We just have not referred to it yet as standard form, but it's called standard form. So I'm going to give you an example of a parabola, and I'm not even going to worry about these a and b values, but we're going to talk specifically about why standard form is important and what key feature it tells us about the graph of a parabola. If I have a parabola that opens down this time, I know that because of this, my a value must be negative. That's important. We talked about that in the notes. If I have this as my y-intercept, then this point is actually the same as my c value. So in this case, I know that my c value is -1 because it crosses at -1. If I have a parabola that opens up, then in this case, my y-intercept is the point 0, 3, and I know my constant term would be 3. Okay? So that's important. Your constant term will be 3. So when you do your Delta Math assignment, if for some reason you can't see the point where the graph hits the y-axis, what do you need to look at? The function. You need to see what that number at the end of the function is. That's going to be your constant term. Again, if this vertex here is at the bottom, it is called a min, and that tells us that our a value is positive. We have a positive a. If our a value, again, is negative, it's going to open down. And this point, this vertex point, still vertex because it's the topmost point, this vertex will be a maximum. So that's what we mean by max versus a min. And that's important because in Delta Math, you'll have to look and go, oh, if my a value is negative, it's going to open down. So again, if I just give you this example of an equation, 2x squared minus 5x plus 15, and I say, what is the y-intercept? Well, the y-intercept is your constant term. So y-intercept, let me write that over, y-intercept always equals the constant term c when in standard form. So that's the big idea I need you to get from standard form is that automatically a key feature we can identify from standard form is our y-intercept, which would be 15. Remember, if it's the y-intercept, I want the y-coordinate to be that number. Got it? And that's all you're going to fill in or add here to your notes about for this graphic organizer. Now, that's going to be important because when we finish this towards the end of the week, you should be able to use this as one reference sheet, one guide to help you understand what key feature will tell you what information. All right? So the next thing I'm going to do is go to Delta Math and help you get started with today's assignment. So I am going to look at problem 1. And it's going to look like this, okay? So the video will be, in a few minutes, uploaded here above number 1. You're going to listen to the video, either print or copy the notes, but fill in the stuff that I wrote down. If I wrote it down, we need to see it in the notes. And you're going to have 6 problems to do, just 6, not a lot. And I'm going to do 2 of them with you. So you're going to do 4 by yourself. So when looking at this, what are some things we know? We know that it opens up. So think about what we just learned about what it means when we open it up, when our parabola opens up. We can see that we have a vertex down here. If we were to look at our notes, you're to decide if it is a maximum or minimum. We have x-intercepts here and here. The y-intercept, oh man, it's off the graph. Oh, we can look at our equation. There's our y-intercept. So whenever you don't see the y-intercept, it's over here on your function. And your job is to simply fill this in. Now, when you get through and hit submit, you will have 5 chances to answer all these, okay? If you do not get it right the first time, just go in and try again. It doesn't mean that everything's wrong, and it's not going to tell you which particular aspect is wrong. If you make it to like 3 or 4 chances and you're like, oh shoot, I don't want to submit it and get it wrong, please take the time to Zoom with us today, to text us a question, send us a screenshot, something to communicate with us that you are trying it and that you need help. And then we can help you with this. So if you joined during Zoom today, we're going to be completing this assignment together. So remember from your notes that your vertex is your maximum or your minimum point. Here we have the lowest point here, and its coordinates are at -4, -4. So that's what I'm going to type in. I'm going to hit Shift 9 to do the left parent and type in -4, -4, then Shift 0 to type in the right parent. So you're going to type this in on your keyboard. Do not put any spaces between negatives, commas, nothing. No spaces. So next I have is called so if you click on it, you have to decide, is it a maximum or a minimum point? Remember that the maximum point is the highest, the minimum is the lowest. So since it's a low point, we're going to choose minimum. And then I ask you for the 0 on the left and the 0 on the right. Remember that your 0 is synonymous with the word x-intercept from your vocabulary. The 1 on the left, and we are going to write these as ordered pairs. If you can't see that number, just remember 1, 2, 3, 4, 5, 6. So that's -6. And since it's an x-intercept, when you type in your order pair, make sure you put -6 in the x spot. No spaces whatsoever, okay? Just left parent, -6, -0, right parent. The 0 on the right, so we mean the right side of this parabola. This is the left side, this is the right side. On the right side, this is at -2, 0. So I'm going to put left parent, -2, 0, Shift 0 for the right parent. Next, the y-intercept is. Now, some of the graphs, you'll be able to identify it by looking at where it hits the x-axis, but a go-to is just always look back up here at the constant term. So remember, y-intercept is 12, so in the ordered pair x, y, this is not the right answer. I'm just trying to show you the x value goes first and the y value is second. The x is 0, and it's the y that is 12. So again, you just need to type in the order pair 0, 12 for y-intercept. No spaces whatsoever. The a value, so remember when we talk about a value, we're talking about the leading coefficient or the number in front of the x squared term. Remember, coefficients are the numbers in front of variables. So if I look up here at my leading coefficient, I don't see anything, so that's an understood positive 1. Remember, the a value must be positive when you don't see a negative. And if it opens up, that also is an indication that our a value is positive. So the a value must be positive because the parabola opens up. So you don't have to look up here, but you can just look at the graph. You can go, oh, it opens up, so my a value must be positive. The equation for the axis of symmetry, so look back at your vocab. Remember that your axis of symmetry is like a vertical line that cuts it in half. When I come down the middle, where is that x? Right there at -4. I can also see it from the vertex, which is right here. So if I write my equation, I'm going to use this x value from my vertex every single time. But I'm going to type in x equals -4. If I do not put the x equals, it will be wrong. Notice I did not put any spaces or anything. Straight up, x equals -4. And the equals key, by the way, is to the left of the delete key in the upper right-hand corner of your keyboard. Remember now the domain here, your lowest x to the highest x for the function is, so remember what we said, it will always be, it goes left forever and right forever, so that's -infinity to infinity. So how you type it in is exactly how I told you to in your vocab. Left parent, hit the negative button, INF, comma, INF, shift 0 to do your right parent, okay? So in parentheses, I have -infinity to infinity. And the reason is I just don't have the capability yet to, you know how before I could add on a square root button and you can just hit square root? I don't have an infinity button I can add on yet. And the range is your lowest y to your highest y. So all you have to do is look at the y from your vertex. Remember, if I were to take a pencil, like I said, you can't see me take a pencil, but I'm taking a pencil with my right hand here, and I'm moving it from the bottom up because it's your lowest y to the highest y. If I were to do that, my lowest y at that point, if you look over to your y-axis, is -4. But it is also the same as the y from the vertex. So my lowest is -4, and remember I told you to put a bracket. So if you look to the right of your P button, P for parabola, you're going to see a left bracket bar, and beside that is a right bracket. So I'm going to hit left bracket, -4, comma, infinity, so INF, and then shift 0 to do a right parent. Does that make sense, guys? The lowest is -4. The highest is infinity. All right, and that's how you would type it in. So at this point, we can submit our answer. And all of this, like if you want, you can take a picture of this because I know when you try again, you might go, I don't know what I entered the first time. So you might want to take out your phone and just take a picture of this, then submit it. And then if it tells you an error, you know what to go back and fix. Okay? So now I'm just going to do one more problem, but I'm going to pick one. Let's see. Notice, guys, sometimes you'll see that in here, this case, there is no constant term. Guess what it is? If you don't see it, it's a 0. All right? So you're going to just do likewise. That's all you're going to do is fill in these blanks. There is no work to submit. I highly recommend you take a picture so it will help you later because you will have questions like these on a quiz. I'm just looking for one that opens down. So here we go. So this one opens down. And I wonder why. Up here, I have a negative in front of my x squared term. So notice this one's slightly different because it's missing that linear bx term, but no big deal. I still have my constant. Remember, the constant term is the number with no x in it. It's the number all by itself. And we're just going to answer it. So here we have the vertex up here. I have a 0 on the left, a 0 on the right. So let's answer. The vertex is this point. The x-coordinate of this point is 0. The y is 14. So I'm going to write 0, comma 14. And you have to decide, is it a max or min? I like to think about, like, if you reach the highest point of a mountain, you've reached the maximum, right? Minimum, like a valley. The zeros are, again, as ordered pairs. I'm going to change this real quick. I forgot to put left or right. But make sure you enter the one on the left and then the one on the right. So the one on the left is -5, 0. Remember, we're finding x-intercept, so put the x value first. And you do have to close it off. What's it doing? Weird. Comma 0. I'm sure I hit something funny. -5, 0, and over here at 5, 0. So you're going to enter in the left one first and the right one next. So left parent, 5, comma 0, right parent. The y-intercept is, it's up here. Again at 0, 14. Interesting. What you're actually going to learn is that whenever your linear term is missing, it's going to be symmetric about the y-axis. So the y-axis is going to split it in half. The a value must be, remember our a value is also the number up here. The a is -0.56. It is negative, which makes sense because it's opening down. So it must be negative because the parabola opens down. The equation of your axis of symmetry is always x equals, where do we find it? The x from the vertex. So x equals 0. The domain, remember what I said, that's a gimme. But make sure we type in -infinity to infinity. And the range, our lowest y, be careful this time, it opens down. So if I were to bring my pencil from below up, my lowest is -infinity. And remember, for negative infinities, we always use a parent. So -infinity, comma, what is the highest y? If I drag my pencil up, the highest y at this point that's the highest is the vertex, the y from that vertex, which I can also find, look right there, 14, that goes in my range. But because it's a number, I'm going to close it off with a right bracket. All right? And that's it. You're going to submit it, and you're going to do the rest of these problems, okay? So definitely you should have 1 and 3 right. One thing I just want to also mention to you, so you know the A, B, and C are not always integers. They can be positive, negative, decimals, fractions, all kinds of things. So just want to show you one more characteristic so you don't get confused. So if you're still listening, good job. Oh my goodness, this one's different in that it does not hit the x-axis. We still have a vertex right here. The y-intercept, we don't see it cross, but remember, this thing is going up and left forever. So eventually, it's going to cross the y-axis. But when I have to identify the y-intercept right here, all I have to do is look to my constant term, because remember, in standard form, the constant term is always the y-intercept. So I would put 0, 73, and it comes from this equation. So you don't always have to see the graph to identify that. The other thing I want to bring to your attention, it says the zeros are. Well, does it even hit the x-axis? No. So I gave you a drop down this time, and you would choose none. So I have in 2 places, so it'll be like the other one, but just choose none. All right, if you're still listening, that means that you should get 1, 3, and at least those aspects of 6 right. But again, please remember, if you are getting it wrong before you get to the 5th try, make sure that you Zoom with us, ask us for help, that type of thing before submitting so you're not frustrated. All right, good luck, guys.